geometry. This isn't considered trig. This is considered geometry. So you have to know that the triangle sum of the triangle, the angle sum of the triangle is 180. You have to know that the angle sum of the straight line is 180 also. These angle sum of the triangle is 180 on the ACT and SAT. So here we go. The angle sum of the line is 180. So that means that's going to be 75 degrees. Now I have to do 180 minus 75 minus 20. So that's going to give me 95 degrees here. Oh, is that 95? I don't think so. That's 105 minus 20. This here is 85 degrees. That means this question mark angle is going to be 95 degrees. 95, 180 minus 85. Try it on the calculator if you don't believe me. No. Has to be angle sum. Once again, geometry idea. Can you see the Z? Can you see the Z? If there's a Z formation, that's going to produce alternate interior angles. So if that's 50 degrees, this angle down here is also 50 degrees. Wait, but shouldn't 85 and the other angle from the other problem equal 180? 85 plus 95 equals 180. Yes? Yeah. Okay. If this angle is 50, this angle down here is also going to be 50. Then these two angles add up to equal 180, so that's going to be 130 degrees. If this angle is 100, this angle inside the triangle is going to be 80 degrees. That there, they add up to equal 120. So this angle has to be 60. You could do 180 minus 80 minus 40. That equals 60. And then this angle is supplementary to this question mark angle, so that question mark angle has to be 120. Again, I have to use Pythagorean theorem to find this third side. So that's going to be the square root of 25 squared minus 7 squared. That's 625 minus 49. That's going to be 576. The square root of 576 is 24. Once I have that as 24, I can now do cosine of A is 24 over 25. Now the Pythagorean theorem problem. They want me to find sine of A. So it's going to be opposite over hypotenuse. So it's going to be something over 13. So I have to use the Pythagorean theorem again. When I'm not finding the hypotenuse, when I'm finding the leg, I have to subtract them. So that's going to be 13 squared, 169 minus 12 squared, which is 144. That's going to give me 25, and that's going to be a 5, 12, 13 right triangle. So the side opposite is going to be 5, and the hypotenuse is 13. This one is purely abstract. Purely abstract. Tells me the sine of angle A is x over y. No numbers, letters. That means this side here is going to be the square root of y squared minus x squared. The cosine of angle A is going to be adjacent. Well, that's the square root of y squared minus x squared over y. Yes, the answer choices are that abstract sometimes. They're higher level with the trig when certain problems. This one is considered a highly challenging problem. What you need to do is draw a helper line. So I draw that auxiliary line, and that makes this a square now. So this base is 10, this side is 10, this side is 10, this side is 10. And if this is 30, this angle here, if it's a square, is going to be 60. This side here, this angle, is going to be 60 degrees. Well, angle sum of the triangle is 180. So that means this top angle has to be 60. If it's equiangular, it's equilateral. So equiangular also means it's equilateral. This side would be 10, and this side would be 10. So they want the perimeter of all those sides. So if I add up all those 10s, I believe it would be 50. Same idea here. Let's do it again. Draw the auxiliary line. It's like a catalyst in a science problem. That's 60 degrees. That's 60 degrees. That must also be 60 degrees. We use the fact that equiangular also implies equilateral. Each side, therefore, is going to be 8. So 5 times 8 is 40. Same idea. This time tick marks are used. If this side is 7, all the other sides are 7. I draw the auxiliary line. That gives me that base is 7. This angle is 60. This angle is 60. This angle is 60. So these two lines on the inside must also be 7. I believe 5 times 7 is 35. More SOHCAHTOA. Abstract SOHCAHTOA. Tangent is x over y. So opposite of A is x. Adjacent to A is y. And the hypotenuse is going to be x squared plus y squared. So cosine is adjacent. That would be y over the hypotenuse, the square root of x squared plus y squared. For this particular problem, you don't have to rationalize it. You can leave the radical in the bottom. It's in the answer choices for multiple choice. On this one, I was about to do all the fancy work, but the cotangent is just a flip of the tangent. So all you have to do is come down here and put y over x. It should go pretty quickly. Sine of angle A is opposite over hypotenuse. It gives me this again. The tangent is opposite over adjacent. The hypotenuse is going to be the square root of x squared plus y squared. Sine is going to be x over that radical. So it's going to be x divided by the square root of x squared plus y squared. Challenge problem. This one's kind of high level. There are more parts to this problem than are presented. All we want to do first is find the radius. ln is actually the radius of the circle that this slice of pi is pulled out of. So that there represents piece of an entire circle. And just a 30-degree piece. Just a 30-degree piece. How many degrees are in the entire circle? 360. So the piece, the part, is going to be 30 degrees over 360 degrees total. And that's going to equal this piece of the crust, over the entire circumference. So it's the small over the large is going to equal the small, 12 pi, over the large. And I don't know what that is. There's a way to figure it out. First, the circumference of a circle is 2 pi r. So I'm going to put 2 pi r, the equation, there. Now I can do some quick simplification. I don't know if you knew this, but I can slice off zeros. That only works with zeros. That only works. You can't slice off the threes. That doesn't work. You can only divide both by 10. Simplify by 10. Can you simplify it even more by doing 1 over? You could, but you know what? Like, it's not fast. I'm working on speed. I think if you divide that by 3, it would be 12. So that would be 1/12. Also, I can do this really quickly. What's pi divided by pi? That is 1. So I can simplify the pi's. Pi is not going to be my answer in this case. And 12 divided by 2, that's 6. So that would be 6 on top. So here it goes. On the calculator, I'll do 6 times 36 divided by 3. 6 times 36 divided by 3. Let's use the calculator for that one, and you would get 72 for the radius. Line equals sine line. 60 is the part. Over 360 is the whole. The part over here, they label is 8 pi. So that's the part of the entire circumference. Over the formula for circumference, which is 2 pi r. I can do some quick simplification. 8 divided by 2 is 4. Pi divided by pi is 1. So that's going to give me a 4 on top. I think I can simplify this pretty quickly. 6 goes into 6 once. 6 goes into 36 6 times. So my arithmetic can be done without a calculator. 4 times 6 divided by 1 would give me 24. So my radius would be 24 if it were on that circle. Line equals sine line. This side over here, this arc is going to be 6 pi. It's going to be 45 degrees over 360 degrees. And then it's going to be 6 pi divided by 2 pi r. So 6 pi divided by 2 pi is 3. And I would need a calculator for this one. 3 times 360 divided by 45. 3 times 360 divided by 45. And that would give me a radius of 24 again. We're asked for the perimeter. So Jackson, I have to figure out what this side length is. If this side is 6, isn't this whole side here 6? So that would be 2. If this whole side is 11, 11 minus 5 would be 6. So some people go ahead and add all these up. To get the perimeter, there is a shortcut to it. All you do is add these two up. And that's 17, and then you double it. And that would be 34. So you could do the arithmetic to find this side. Some problems require you to do that. The arithmetic to find this side. Sometimes the problems require you to do the arithmetic to do that. But for this basic shape, I can just like fold that point out to there. Now I get the same distance, the same perimeter. So 8 plus 11 is 19. And 19 doubled is 38. 9 plus 5 is 14. 14 doubled is 28. Again, this is nested in a big word problem. I'm just showing you a picture. It says that this here is a square, and its center of this square touches the center of that square. The center of that white square touches the center of the shaded region of that square. Area of the shaded region is what we're looking for. Area of the shaded region is actually 3/4 or 75%. So 3/4 of this area. So if it's a square, 8 times 8 is going to give me 64. So 0.75 times 64. And I believe that area would be 48. Again, 10 times 10. The area of the entire square would be 100. But let's face it, 75%, 0.75 of 100 is just 75. You would do 0.75 times 100. And yes, you would get 75. Let's recall that root 6 times root 6 is root 36. And the square root of root 36, the square root of 36 is just 6. So if this side is root 6, the area is going to be 6. And 3/4 of 6 is 9/2 or 4.5. What I would do is I'd hide that left part of the problem. I'd hide the left part of the problem. And now, angle sum of the triangle, of this half triangle, or part of the triangle, is 180. Now, I already have 90 degrees down here. So the two acute angles of a right triangle always add up to equal 90. So 2b equals 30 degrees. Because 30 plus 60 equals 90. So 2b equals 30. I believe b would equal 15. 15 and 60 and 90. So this would be 15 degrees here. Now let's take a look. Angle C is going to be 90 minus 15. Because these two angles add up to equal 90. So it's 75. Now that that's hidden, I don't know what 90 minus 34 is. It might be 56. Yeah, 56 plus 34 is 10. Yeah, that's 90. So 2b equals 56. Divide both sides by 2. That's going to be 28. So the angle in the hidden triangle is 28. 90 minus 28. 2. Borrow 62 degrees. 2b has to equal 40 degrees. What's 56 divided by 2? But shouldn't 2b equal 34? No, this angle and this angle add up to equal 90. Alright, so I do 90 minus 34 is 56. And then 2b equals 56. Over here, this is 40, so b is going to equal Bente, 20. So when I put that 20 here, c is going to equal 70 degrees.
You ready? So what they're trying to do is get around the fact that some people haven't taken pre-calculus and don't know the unit circle, so do a clock problem. The clock problem is kind of a unit circle problem. They want to know how many degrees it is from 1 p.m. 1 to 8. It doesn't matter if it's p.m. or 8 a.m. or a.m. All right. So from 1 o'clock to 8 o'clock. And here's what I like to do first. Like, let's get something out there in the open right now. How many degrees is it from 1 to 3? 90. And then you have 1, 2, 3. So that means every hour or every 5 minutes, whatever, however you want to look at it, is 30 degrees. So every one of those sections is 30 degrees. And if you've done the unit circle, I think you know that like they deal with 30 degrees a lot on the unit circle. So from 1 to 8, let's see what happens. If I go right across 180 from 1 o'clock, I think it hits 7 o'clock, doesn't it? So from 1 to 7 is 180 degrees. And then I'm going to go to 8 o'clock. So that's 180 plus another 30. So that's going to give me 210. You picking up what I'm putting down? From 1 to 10, 1 o'clock to 10 o'clock. There's 1 o'clock, there's 10 o'clock. I can do the same thing. I like to strike it across. So that's 180. And then people do this different ways. They come up with different ways to do it. So you can say it's 360 minus 90 or 180 plus 90. And that's going to give me 270. That's going to give me 270. 3 o'clock to 8 o'clock. So there's 3 o'clock and there's 8 o'clock. So again, if I draw that line straight across, that makes the arithmetic a little bit quicker for me at least. So that's going to be 180 minus 30. 180 minus 30. So that should be 150 degrees. Should be 150 degrees. Sometimes they have the clock problem on there. Sometimes they don't. One year when I was doing an SAT prep, they said, don't do it, skip it. And guess what? The next day, it was there. The clock problem showed up. The ribbon or tape. They're taping up a box. And they want to know how long the ribbon is combined. So this one's kind of tricky. And what they're trying to do is to see if you can tell what's hidden behind the box. You got to account for the ribbon that's hidden behind the box. I can't read that. It's got covered up. How high is that there? Is that 10 on the paper? 12? 20? So I'll put it over here. It's 20 high. It's 20 high. So there's a 20 there. So we have to count up the ribbon. Now, I'm going to do a nice visual for this. I'm going to look at this vertical. How high is that? 20. So I have a 20 here. And don't I have one that's hidden back there? And then there's another one that's hidden back there. So I have 4 of them. And I actually draw the toothpicks. Like 1, 2, 3, 4 times 20. So that's going to equal 80. That's going to equal 80. Can't be F. Okay? It can't be F. Now we have this 13. See this 13? So that's the one going on the diagonal. And there's only 2 of them. Right? There's only 2 of them going on the diagonal. There's no tape going this side. So it's just on the top and there. So that's 2 of those diagonals times 13. And that's 26. So that's 106. All right? And now I got this long one, 40. There's a long one there. And there's only one more of those going down along the bottom. So that's 2 of them long ones times 40. So that's going to equal 80. 80 plus 80 is 160. 160 plus 26 is the 186.